Hey guys, it's Mr. Neve here today. So today I'm your substitute for your math class and your teacher, Mr. Neve. All right. He gave me some work for you guys to do. So yeah, why don't we get into it?
Wait a minute. Get out of here. We don't need you here today. I'm here. I'm teaching this class. But he brings up a really good point. He was going to be representing me. He was my substitute today. And then what we're going to be doing today is we're going to be solving more systems of equations, but we're going to solve those systems of equations by using a technique that's called substitution. If you remember when we were solving our systems of equations and we were looking at how the two lines crossed at a certain spot and that was the solution to the system, sometimes that solution wasn't very clear. Either it was off our graph or they might have crossed and it wasn't on a whole number. So sometimes graphing a system is not the best technique to use. So we need to have another method available to us. That's where we're going to use this method called substitution. So there's a couple different ideas that I want to show you. The basic idea of substituting is that we're going to take two things that are similar and make an equation and show how they are like one another by taking something and substituting it in for something else. All right, so the first example I want to show you is right here. This basic idea. If we know that x is equal to a and x is equal to b, let's see how well a non-trained, unprofessional knows this. Come on over here, person who I've never met before and has not been prepped in this at all. So if we know that x is equal to a and x is equal to b, what else do we also know?
Well, wouldn't that mean that a is equal to b?
That's exactly what it means, because what we see is if we know that x is equal to a and x is equal to b, we also know that a is going to be equal to b. Those two things have to be equal. It's like we substituted, because I'm saying x is the same as a, so we can substitute that a in for x. We substitute this in, or because x is equal to both of these must be equal as well. All right, using that same logic, let's give you a little bit tougher one. If we know that y is equal to x plus 1 and y is equal to a plus 3, what else do we know?
Wouldn't that mean that x plus 1 is equal to a plus 3?
That's exactly right. So we know that because y is equal to each of these things, the y plus 1 and the a plus 3, therefore we know that these two things must be equal as well. And we could write a new equation. X plus 1 is equal to a plus 3. So that right there is the basic idea behind substitution. We're going to do a few more examples and we'll see how it goes. As we've discussed, when we're solving these systems of equations, we're looking for that point that solves each one of these equations. Now remember, each one of these equations, when we graph it, forms a line. And in theory, easy way we can find the solution is by graphing one line, graphing the other line, and where they cross is the point that solves both of them. But sometimes we get special challenges where actually graphing it isn't going to be very useful for us. For example, in this system right in front of you here, the first equation has a y-intercept of 11. So trying to figure out where that is on my graph is going to go off the board and it's not going to work really well. So this is where using this technique called solving by substitution can be really helpful. Well, as we started discussing, what we do is we're going to substitute or plug in one thing for another. As you can see here with these two equations, we're saying that y is equal to 2x plus 11, but we're also saying that y is equal to negative x plus 5. Well, if you think about that idea where we discussed a is equal to b and b is equal to c, that means a must be equal to c, because if both of these, 2x plus 11 is equal to y, and negative x plus 5 is also equal to y, then that tells us we know that 2x plus 11 has to be equal to negative x plus 5. Now you might say to yourself, well, great, now all we did was make a tougher equation. But remember, the goal is we're trying to find out what value of x and y will solve both of these. This is going to allow us to find out what our x value is. Solve this equation for x. So we're going to get our x's on one side of the equation by adding x to this side. and to this side. That gives us 3x plus 11 is equal to 5. Solve by subtracting 11. We have 3x equals negative 6. We divide by 3. And we get x is equal to negative 2. Now, it feels like we're done, but we're not. What we have now is we know that the x value of our ordered pair is negative 2. Now, we still have to figure out what our y value is. Now, here's what we do. We're going to take this and plug it in either here or plug it in the top one. You can pick whichever one you want. I'm going to start with the top one. Now, in theory, it should work for both of them because it solves both equations. It's a good idea, actually, to plug it in and check that it works in both of them. So we get y is equal to 2 times negative 2, because that's what we solved for the bottom, plus 11. 2 times negative 2 is negative 4, plus 11 is 7. Negative 2, comma 7 is my solution to this system. And if you plug this in to the other one, you'll see it solves that as well. The opposite of negative 2 is 4. Sorry, the opposite of negative 2 is 4. Plus 5 is, sorry, the opposite of negative 2 is 2. Oy vey. Plus 5 is, in fact, 7. All right, let's do another one. See if I can avoid screwing this one up. So we've got these two equations. Y is equal to 4x plus 7, and y is equal to 15. Well, if we know that y is equal to 4x plus 7 and y is equal to 15, then we know that 4x plus 7 has to be equal to 15. It's like we just took this 15 and substituted it in for that y, hence the name. All right, we have an equation with just x's here, so let's solve it. We're going to solve this, and this will tell us what our x value is. You're going to need paper and pencil for this. X is equal to 2. Now, this one's kind of simple because we need to still figure out what our y value is. Well, it tells us right here, y is 15. So we know y is 15. But we could check it too, because if we took that other equation, y equals 4x plus 7, and we plug the x in here, y is equal to 4 times 2 plus 7, which is just y is equal to 8 plus 7, which means that y is equal to 15. So 2 comma 15 is our solution. That's the ordered pair that plugs in here and here and makes it true. All right, here comes another one. So once again, we know that y is equal to 3x minus 12, and we know that y is equal to 5x. Since y is equal to both of those things, then we know that 3x minus 12 has to be equal to 5x. It's like we substituted in for y. So we solve for x, get x on one side. We get negative 12 equals 2x. We divide by 2. And we get x is equal to negative 6. Now remember, that's only part of our solution. We need to find our y value. So we plug in to either of these equations. I'm going to take the second one. Y equals 5 times negative 6. I know that y is equal to negative 30. Bingo. And we could actually check it. I'm going to check it too. So let me check it in here, because it better work in both. I'm going to plug in negative 30. Is that equal to 3 times negative 6 minus 12? Well, 3 times negative 6 is negative 18. Minus 12 is, in fact, negative 30. So that's going to get most of you by for your homework. But I got a challenge one right here. This one's a little bit more involved. Now, this one, they're not both written y equals. Now, you could take this top one and we could solve it for y. We could move that 3x to the other side. Or, remember, we're saying that y is 2x minus 6. So that means that here, where we see what a y is, we can replace that y with a 2x minus 6. So we can take this top equation, 3x plus, now instead of putting a y there, we know that y has to be 2x minus 6. So let's write 2x minus 6. And that has to equal 4. All we did was we took that 2x minus 6 and replaced it for that y. This is now an equation that we can solve. We have 5x minus 6 equals 4. We add 6. We get 5x equals 10. Divide by 5. We get x is equal to 2. Want to find out what y is? Plug it in. Let's take one of those. Y equals 2x minus 6. I'm going to plug in a 2 for x. So we got y is equal to 4 minus 6, which means y is equal to negative 2. The solution to our system is 2 comma negative 2.
All right, I think I get it now. If we know what y equals, we can substitute that into the equation for y. So see here, y equals 2x plus 3, and y equals 3x minus 1. We get 2x plus 3 equals 3x minus 1.
All right, that's pretty good, but you're in my spot. All right, so what you guys are going to have for the rest of the day here, you're going to have some other videos we need you to watch. You're going to have some practice to work through, and ultimately you're going to have a homework assignment. This is not an easy thing to do. There's a lot of algebra involved here. You are absolutely going to need to have paper and pencil with you. This is not something that you can just watch and see happening. Have your paper and pencil out. You're going to have to work through that algebra. It's too much stuff to keep straight in your head. So paper and pencil, every single thing we're doing from here on in. Plan to have it. Watch the videos, and if you're having any questions, please reach out to one of us. Have a great day.